Section 9.7, Circles and Lengths of Segments. In this particular section, we're going to be looking for the lengths of the segments that intersect circles or are tangent to circles. The first theorem says when two chords intersect inside a circle, the product of the segments of one chord equals the product of the segments of the other chord. Looking at the two chords on the inside, 4 times 6 equals 3 times 8. If you try this problem, you would set it up as 4 times 12 equals 6 times x. 4 times 12 is 48, so 6 times x equals 48, and x equals, let me know. The next theorem says when two secant segments are drawn to a circle from an external point, the product of one secant segment and its external segment equals the product of the other secant and its external segment. Sounds like a lot of words, but basically this is what happens. Notice that you have secant AX. The external part of secant AX is BX. Secant CX, external part DX. The words that are in this entire theorem can be repeated or broken down to be this. Whole times the external part equals the whole secant times the external part. In terms of this particular problem, AX times BX equals CX times DX. The whole entire segment AX times the external part, the whole entire segment times the external part. If you do the math, 13 plus 3 is 16, 16 times 3. 8 plus 4 is 12 times 4, and you'll find out that both of them equal 48. Try this problem. Remember, whole times the external part equals whole times the external part. Again, AX times BX has to equal CX times DX. Please solve this problem as part of your notes. The next one is very similar to the last one. We're talking about an external angle and an external point. But this time, instead of talking about two secants, this deals with a secant and a tangent. When a secant and a tangent are drawn to a circle from an external point, the product of the secant and its external segment equals the square of the tangent segment. Take a look here. Because it doesn't have a second part to CX, we've got to have some kind of a product. So we use CX twice. So in this case, in this particular picture, the whole entire secant times its external piece is equal to the tangent times itself. 20 times 5 is 100. 10 squared is 100. Now you know that those two are equal. What I'd like you to do is solve this problem for me and have it ready for tomorrow. Remember, whole times external, tangent squared.